How does one discover life on other planets? Well, the first thing you need are other planets. Going around our sun are 8 planets, plus Pluto and a bunch of moons and lots of other stuff. But it's a small selection. So your best bet is to look for planets going around any and all stars. Our galaxy alone has 100 billion stars in it, and so there is a lot of hope of seeing an enormous amount of planets as long as we have a way of seeing them. Here are some ways you can see planets going around other stars. The first is the transit method. The transit method is a method of seeing a planet by watching for it block the light of the star. In other words, if the planet is reasonably big compared to the star, when it orbits the star, it could get in our way, and we would see that the light from the star dims and then brightens again, with this very specific pattern which would be caused by a planet transiting in front of it. And in fact, at this point, thousands of planets going around other stars have been seen using the transit method. A second method that people use is a method basically looking for the wobble of a star. A planet like Jupiter can be quite heavy, even compared to the star, such that when it goes around the star wobbles. And when it wobbles towards and away from us, it shifts the frequency of light that's coming towards us. It's called a Doppler shift. And that Doppler shift, happening at a very regular period, tells us that there's something heavy going around it. A third way is if stars and planets pass in between us and more distant bright stars. That passing can cause the light to be warped a little bit. It's called gravitational lensing, predicted by Einstein. All these methods and more are hopes for seeing thousands, tens of thousands, even hundreds of thousands of planets in the near and immediate future. But then you want to figure out if there's life on any of those planets. How are we going to do that? Well, the best bet is to look at the atmosphere. The atmosphere will contain all kinds of chemicals, and those chemicals could have been naturally there due to the formation of the planet in the first place, or they could be there because something interesting is happening on the surface of the planet. Giant planets like Jupiter and bigger naturally have water in their atmospheres, but tiny rocky planets shouldn't. And they shouldn't because sunlight breaks apart water, and hydrogen is so light it wants to escape light planets. So look for small rocky planets that have lots of water in their atmosphere. Already that will suggest that there is water on the surface of the rocky planet, like oceans. It doesn't prove there's life on the planet, but at least now we're getting more evidence, and we're seeing ways of seeing planets that look more and more like the Earth. A final stage would be to look at that atmosphere and find other things in the atmosphere with abundances, amounts that are unexpected to occur simply naturally. One of those is, for example, oxygen. Oxygen can be something which is produced by living organisms. So if you look at a planet and in its atmosphere there's water and there's large levels of oxygen and perhaps other chemicals that we might expect to be produced by the processes of life, then we start to have strong evidence for the existence of life. To really go the final step, you need really provable theoretical models of what life can and cannot do and what non-life processes can do, and put chemicals into the atmospheres too. How are we going to be sure? We don't know, other than, let's say, direct communication with the intelligent beings out there. However, we do see a path to get closer and closer to eventually answering that question: are we alone?